In a small town near a once important site of the Belgian steel industry lies a decommissioned, long-abandoned lime plant. Here, the limestone quarried from the adjacent site was converted into quicklime through a process known as lime burning. The plant was built around 1889 and was once an important site for lime production. Over the years, it was repeatedly modernized until it was likely shut down following the economic crisis of the 1970s. Join us as we explore this historically rich lost place. The lime kiln is nicknamed Usine Pinokkio, inspired by its most iconic photo subject, the distinctive combustion chamber with its gas burner pipe, reminiscent of the long nose of the wooden boy it's named after. The lime plant consists primarily of two main buildings, connected by a long steel pipe, the Rotary Kiln. In the charging tower, located in the rear part of the image, the raw limestone material, calcium carbonate, was stored and fed into the kiln. Additionally, the building served to filter the exhaust gases produced during the process. The raw limestone material was transported up into the tower and into the dosing bunker via conveyor belts. Limestone is a naturally occurring sedimentary rock composed primarily of calcium carbonate, CaCO3. It was formed by the accumulation of shells, corals, and calcareous algae in a prehistoric shallow sea. Geologically, it dates back to the Devonian period and is therefore around 400 million years old. From the hopper of the dosing bunker, the limestone drops into the rotary valve, a mechanical metering and conveying device for bulk materials like limestone. The individual chambers of the rotary valve's conveyor system are filled with limestone in a controlled manner and then directed in measured quantities into the shaft leading to the rotary kiln. The limestone was fed into the rotary kiln via the feed chute. The rotary kiln is an approximately 80-meter long, slightly inclined steel tube that slowly rotates at about 1 to 4 revolutions per minute. Through this rotation, the limestone gradually moved from the so-called cold end at around 200 degrees Celsius toward the gas burner. The furnace end heated to approximately 1100 degrees Celsius, where it was transformed into quicklime. The rotary kiln is lined with fireclay bricks to withstand temperatures of up to 1100 degrees Celsius and to efficiently retain heat. At the hot end of the rotary kiln was the gas burner, which continuously heated the limestone to up to 1100 degrees Celsius, thereby transforming it into quicklime. Here, the hot quicklime falls through openings in the rotary kiln into the so-called planetary cooler. The planetary cooler consisted of ring-shaped chambers arranged around the rotary kiln, which rotated together with the kiln like planets around the sun, hence the name. During rotation, the material was passively carried along inside, while air was simultaneously passed through, cooling the lime. At the end of the rotation, the finished quicklime fell through an outlet in the planetary cooler into a discharge hopper, where the material continued to cool down. Next to the building housing the burner and the planetary cooler is the elevator tower. This tower was used to transport the finished quicklime from the discharge hopper upward, so it could be sorted, classified, and then distributed into various silos or loading facilities.
Das hat Vorteile.
Aber ich komme da gerade nicht.
Hände, ne?
Bitte?
Du hast gar keine Hände für, ne?
Nee, gerade nicht. Also doch eine, aber die ist nicht so lang, weil du so lang bist.
Also, die sind offensichtlich noch ein bisschen schlanker als ich.
Wahrscheinlich.
Ich bin jetzt ja fast durch. Wir können es ja probieren.
Mhm.
So.
On both sides of the inclined ramp run the conveyor chains of the bucket elevator, continuous chains with metal scoops that pick up the quicklime at the lower end. As they move up the ramp, they transport the material into the tower, where it is emptied via a deflection wheel and further distributed. A narrow maintenance walkway runs along the center of the ramp. Since the quicklime did not exit the kiln uniformly, but as a mixture of various grain sizes, it was sorted here according to size and transported into separate silos. For this purpose, vibrating screens were used. The material was shaken and passed through sieves, falling into different silos depending on its size. Beneath the silos is the silo discharge, through which the lime was loaded onto trucks. In the building at the cold end of the rotary kiln, where the raw material was introduced, the hot exhaust gases flow back against the material stream and exit the tube at that point. The exhaust gases are directed into a filter and gas treatment section, where coarse particles and dust are first removed in a separator. The gases then pass through an electrostatic precipitator, which captures fine dust particles and bound lime. These dusts often contain valuable residues and are partially returned to the process or used as fillers. Only after this are the cleaned gases released into the environment in a controlled manner via the chimney. The quicklime produced here was used to purify molten pig iron in the blast furnace or converter from undesirable impurities. The highly reactive quicklime primarily binds sulfur and phosphorus, which would otherwise impair the quality of the steel. In addition, it promotes the formation of a thin, free-flowing slag that absorbs impurities and can be easily separated from the metal. Without quicklime, the large-scale production of high-quality steel would be virtually unthinkable.
Geht's dir gut?